Hello, my name is Alvin from Section 5 Programming. Before I start my presentation, I would like to send greeting to Dr. Zaini Yunus. Okay, for my presentation, it will include introduction, problem statement, and also the objectives, methodology as well, and a conclusion. Okay, first of all, fluid mechanics play an important role in the engineering field. So the project I want to present today the parameter of fluid, which is Reynolds number, which is a dimensional quantity that describes the flow type of fluid, flow pattern of water or fluid, either water or air. Okay, but in this case we are going to further describe for the water, for the liquid. Okay, and so that for chemical mixing, there are for different type of Reynolds number, it will show different pattern of flow of fluid. And then first of all is laminar, and then transitional, and then turbulence. For laminar flow, it is show that Reynolds number of fluid or liquid below 2100, and then above than that it categorized as transitional, which below 4000, and above 4000 it will be turbulence flow. So the four type of pattern is the degree of disorder is increased, as well as the Reynolds number. When the Reynolds number become higher, the disorderability of fluid flow is increased, which means that turbulent liquid flow disorderly compared to the laminar flow. Okay, that is different application that we want to use. For example, for laminar we are using in different, with one liquid become laminar at specific condition, as well for turbulence. For example, mixing of chemicals, because we want to the chemical mix well, so we have to make sure the liquid is in turbulent flow so that they can mix well, because the flow type pattern is this disorder. Okay, and the objective of our project is to provide optimized parameter of fluid flow to produce turbulent flow from chemical mixing reaction, and to apply programming knowledge for customization solution in order to solve engineering problem to create a program related to fluid parameter, which is the modification process of fluid parameter in order to achieve Reynolds number more than 4000. Okay, which means that we have a fluid and the parameter as we want to complete the calculation for Reynolds number. And then if that parameter is not enough to achieve to get turbulent flow, I use in this program to achieve that by changing the value of parameter inside the formula of Reynolds number. Okay, for the methodology, we are using the Reynolds number equation, which is the density times velocity and effective length over the fluid viscosity. And then the flow chart can be seen in the report in the program as well, and also the result. And we can get that if we input the value of viscosity is 0.05, pressure in 700, and velocity in 2, and the length characteristic is 0.05. and we can get that new parameter which can make it become turbulent flow, such as dynamic viscosity, changing of the dynamic viscosity to 0.017492, which is precise. which is precise to achieve the turbulent flow of fluid. Okay, or else we can change constant the other value and change by changing the density become 2000.000122 to achieve the turbulent flow as well as flow velocity, which is 5.714371, and the length characteristic 0.14202. We can choose either each of the parameter by changing and then to achieve the turbulent flow of fluid. Okay, so then in conclusion, we can choose either which parameter we want to change, because it is difficult to change the viscosity of fluid if we want the chemical or liquid as a constant, because for example, for water, we want to increase the viscosity, we need to heat it up, and maybe more energy is required for heating purpose, and increase the dynamic viscosity. And it is more simple when we change the parameter of velocity of fluid, right? And then we can choose which one we want to change, and then which one is more effective that will changing the flow of fluid become turbulence. And then as well as because our program is changing of increment or decrement in very precisely 0.0001, and then so that it is precise in our program compared to manual calculation, which consuming time. Okay, I think this is all for my presentation. Thank you.